Welcome back to Easy Chemistry by Vennela. Today, reactive intermediate, second one is Carbanion. So, in this, first one is structure. What is hybridization of Carbanion? Hybridization is sp3. What is bond angle? 109.5. Next, geometry is pyramidal. This is also trivalent carbon. It has octet electronic species. It is unstable, highly reactive, diamagnetic nature. This is nucleophilic character. Carbanion means this is negative charge. This is isoelectronic and isostructural with ammonia. Next, second one is generation. NO2CH3 in the presence of base NO2CH2 minus. Next, CnCH3 in presence of NaOET. It forms CnCH2 minus. Next, it reacts with dilute NaOH. How it forms? C double bond O CH2 minus. Next, third one is stability. What is the stability order for carbanion? If it is electron withdrawing group, increases the stability of carbanion. But in carbocation, it will decreases. ERG decreases the stability of carbanion. Carbocation increases. Next, fourth one is detection. It is identified by negative mass spectrometry. CH2 minus M by Z is equal to 15. Next, CH3 CH2 minus M by Z is equal to 29. How it is 15 and it is 29? I already explained in the carbocation. Check it once. Next, fifth one is chemical reactions. Chemical reactions mainly 5 types. First one is CC condensation, which is nothing but addition reaction. Second one is elimination reactions. Third one, substitution reaction. Fourth one, chain lengthening reaction. Finally, fifth one is rearrangement reactions. In this, first one is CC condensation reaction, which is addition reactions. In this, CC condensations are, one is aldol condensation, benzoin condensation, benzoic acid rearrangement. Next, Claisen reaction. Next, Claisen condensation. These both are different. Next, Digman reaction, Perkin reaction, Noe-Vennekel reaction, Michael reaction. This is very important reaction. Next, finally, Riemann-Diamond reaction. Phenol reaction with CH3Cl NaOH. It forms aldehyde, which is orthosalicyl aldehyde. This is para-salicyl aldehyde. This is RTR, Riemann-Diamond reaction. Next, phenol reaction with dilute NaOH, CO2. It forms carboxylic acid, that is orthosalicylic acid. This is aldehyde, this is acid. Next, this is para. Next, second one is elimination reactions. This is pyridine to carboxylic acid. Pyridine to carboxylic acid. This migrates here lone pair attack here. In the presence of thermal, it forms like this. It forms like this. By removal of CO2, finally the product like this. It migrate here. This is the final product. After that, COOH and here there is no decarboxylation. Why? This COOH group is far to this nitrogen, so that is why here no decarboxylation. Next, third one is substitution reaction. Here double bond O, hydrogen, NaOET, it reaction with NaOET. How it forms? Here negative charge. That reaction with methyl bromide. Here bromine is leaving group. This attack here. Finally, it formed like this. Methyl here double bond O. Here O. This is the substitution reaction. Next, fourth one is chain lengthening reaction. It reaction with NaNH2. It forms like this. It reaction with CH3Br. It forms C triple bond C. Here CH3. Again it reaction with CH3Br and NaNH2. It forms final product like this. Fifth one is rearrangement reaction. In this rearrangement reaction, first one is Steve rearrangement. Here quaternary ammonium. This is quaternary ammonium. Reaction with phenyl lithium. This is positive and here partial negative charge. It forms like this NCH. Here negative charge is there that react with this CH3, attack with CH3. It forms CH3N nitrogen. Here lone pair is there. Here CH3. Here CH. This migrate here. So here this is CH3. Finally phenyl. This is tertiary amine. Quaternary ammonium to tertiary amine. That is Steve rearrangement. Next, second one is Witting rearrangement. What is Witting rearrangement? It is ether can be formed into alcohol. Ether, this is ether, CH3, CH2, PH. Phenyl lithium, this is ether. This attacks here. It forms like this CH3C negative charge, phenyl. Here like this, here attack like this. This is 1-2 rearrangement. Here negative charge is there, CH, phenyl, CH3. So finally water, so it forms like this. This is alcohol. Ethers to alcohol. This rearrangement is Witting rearrangement. Next, third one is Somlet-Hauser rearrangement. This is also quaternary ammonium. This is quaternary ammonium. It reaction with phenyl lithium. It forms like this. CH2 negative charge, CH3, CH3, CH3. After it forms like this. CH2, CH2 here. This negative charge migrates here. Here 2, 3 rearrangement. CH2N CH3. Here hydrogen is there. This hydrogen here CH2 forms CH3. Here CH2 nitrogen CH3. Finally it forms tertiary amine. Final rearrangement is Favorsky rearrangement. Here C double bond O CH2 bromine. This is alpha halo ketone. It reaction with NaOET in the presence of base. It forms phenyl. Here negative charge is there. Forms negative charge. See, this negative charge migrates here. So finally it forms phenyl CH2. Here C double bond O. This is cyclopropanone. This is intermediate for Favorsky rearrangement. What is the intermediate for Favorsky rearrangement? cyclopropanone. It reaction with NaOET. This is nucleophile. It forms like this: phenyl, CH2, here carbon, here OET. This negative charge migrates here. After this one migrates here. It forms like two products. First one is phenyl CH2 negative charge, C double bond O OET. Next, another product is phenyl CH negative charge, CH2 C double bond O OET. This is stable product. This is unstable product. It reaction with water. Finally, it forms ester. It forms esters. Alpha haloketone. It forms ester. This is the Favorsky rearrangement. So this is the end of the Carbanion.